Okay, welcome to another video. We're going to move on to the new topic for real this time. It's going to be L2 circuit, so we'll start the same way as we start every video. Alright, looks like we've got lots of good documentation here. Perfect. So let's pick some out to look at more closely. So here we've got a whole example of L2 circuit topology. So I think this is what I'm going to be going with. Last video we found a troubleshooting guide for L2 VPNs. And we learned that you need a different kind of IBGP configuration for L2 VPNs. You need a full mesh amongst the PEs instead of a full mesh amongst every single router in the topology as is required for L3 VPN. So we just changed that and it started to work. Okay, so yeah, let's start by reading the initial. Oh, oops, you have to have a more than just that. Okay, I'm curious about the encapsulation type because I think this is where we need family VPLS. Yeah, here's where we can have Martini versus Compella. Yeah, virtual circuit ID. This is the kind of thing I have a lot of experience with. So let's just jump right to the example. Okay, so this is Introduction to Layer 2 Circuit Protect Interfaces example. This example illustrates how you might configure a Layer 2 circuit with Protect Interfaces. Protect interfaces, I made some water to act as backups for their associated interfaces. The primary interface has priority over the Protect interface and carries network traffic as long as it is functional. If the primary interface fails, the Protect interface is activated. These interfaces can also share the same virtual path identifier, VPI, or Virtual Circuit Identifier, VCI. For more examples on how to configure Layer 2 circuits, see the Junos feature guide. Layer 2 circuits using Protect interfaces shows the network topology used in this example. Okay, so let's take a look at the network topology. I might go my own way and use my own topology. So yeah, it looks like it's similar to the topology I'm using. It's just that I have one more endpoint, and then we'll pick out one of probably the connection between R1 and R4 to have the Protect interface applied to, and then the rest we won't have Protect interfaces. Okay, so we've only got these routers. We won't need to mess with the P routers. So let's pull up the example configuration for CE1, save that in Notepad, as well as the example configuration for PE1, save that in Notepad, and then get a glass of water. So it looks like we've got frame relay going on. Won't be using that in my topology. Hopefully that's not on the test. Frame relay is kind of a addiction that the networking world seems to have, and I've never encountered it in the real world because I just don't see why a company would be using frame relay for anything. Okay, so now we're going to take the PE example. Okay, so we've got everything set up for when I come back. I'm going to get a glass of water. I'll be right back. Okay, welcome back. Let's keep moving on this. So, okay, so here we just have a frame relay configuration. It's basically just, perhaps this is like a indicator for like frame relay. Yeah, would be a reason you'd want a L2 VPN. Yeah, it would be a reason that you would need one. You'd require a L2 VPN if you were using frame relay. You can also just have a Ethernet port. So I don't think it matters too much L2 or L3 connections, but if you have frame relay, you're definitely going to need a L2 connection. Okay, so here's what we need for L2 circuits. So let's try this. Let's just try configuring an L2 circuit. I kind of want, so I kind of left a little bit high and dry with that documentation. So let's see if there's anything better using a Google search. Okay, this looks good. Yeah, this looks really good. Okay, so here's common configuration for all VPNs. Okay, so that'll be necessary eventually. I kind of want to read that right now, but I think it would be better to read that when I go to L2 VPNs. Okay. Yeah, so let's just try to use this here. This could be a short video. I have professional experience doing this. So yeah, I think all we're going to need is a neighbor, virtual circuit ID, and then if we want a control word, we can have it, but it's easier without one. Because the control words must match, it's just an extra. It's like a password. Really, once you're this deep into it, it doesn't really matter to have passwords on individual L2 circuits. It's just getting a bit crazy with security, which, I mean, if you're in government, something like that, you might want something like that. But once they're in this deep, I mean, it's already too late. Okay, so yeah, let's try to set up a L2 circuit. Okay, so we've got to have an interface. So this is going to be a customer-facing interface. Okay, so the customer-facing interface is GE000. Okay, so I think what we can do is make our own interface. So let's do edit interface GE000. Okay, now this is not going to be a VPLS interface. This is going to be an interface for an L2 circuit. So we're going to need to use a value lower than 512. Let's go with 100. Okay, and then we're going to enable family MPLS. Okay, and then we're going to do edit L2 circuits. We'll go back here. And we'll do set interfaces, about 100, set virtual circuit ID 100. Oh, we've got to do edit. Yep. Okay, so I think that's how it goes. Let's see if there's any other options for family that look a little bit better. So one thing we could set it as is CCC instead of VPLS. I think that's what it's meant to be at. Let's try VPLS for now. I wish they would give it just straight up, but unfortunately, here we go. So here's the documentation that's going to be helpful to this, so I will include that. A layer 2 circuit is a point-to-point layer 2 connection transported using multi-protocol label switching, MPLS, or other tunneling technology on the service provider's network. A layer 2 circuit is similar to a circuit cross-connect, CCC, except that multiple virtual circuits, VCs, are transported over a single shared label switch path, LSP, tunnel between two provider edge PE routers. In contrast, each CCC requires a separate dedicated LSP. The Junos OS implementation of Layer 2 circuit supports only the remote form of a Layer 2 circuit. That is a connection from a local customer edge CE router to a remote CE router. Figure 1 illustrates the components of a layer 2 circuit. So a layer 2 circuit has a local CE router and a remote CE router, and it has a local CE interface that connects the two. Your configuration is going to go here, and then it's got a VPN label and a tunnel LSP label. So hopefully it will work. To establish a layer 2 circuit, the label distribution protocol, LDP, is used as the signaling protocol to advertise the ingress label to remote PE routers. For this purpose, a targeted remote LDP neighbor session is established using the extended discovery mechanism described in LDP, and the session is brought up to the remote PE loopback address. Because LDP looks at the layer 2 circuit configuration and initiates extended neighbor discovery for all layer 2 circuit neighbors, the remote PEs, no new configuration is necessary in LDP. Each layer 2 circuit is represented by the logical interface connecting the local PE router to the local customer edge CE router. Note that LDP must be enabled on the LO0.0 interface for extended neighbor discovery to function correctly. Packets are sent to remote CE routers over an egress VPN label advertised by the remote PE router using a targeted LDP session. The VPN label is sent over an LDP LSP to the remote PE router connected to the remote CE router. Return traffic from the remote CE router destined to the local CE router is sent using an ingress VPN label advertised by the local CE router, which is also sent over the LDP LSP to the local PE router from the remote PE router. Okay, so I think these three examples are going to be the best. So they're using encapsulation CCC. Let's see what it looks like for the different kinds of VPNs. Encapsulation CCC. Okay, so I think I need... Yeah, I'm actually pretty confused. Let's just go ahead and try it as I have it here, and I think it will fail, but that's okay. It'll be a learning process. And the thing I'm worried about, though, is that it might fail because it's part of a VPLS, and that's where it gets complicated, in my opinion, is modifying that sort of configuration. So I'm hoping it doesn't get super complicated, but I'm going to need to understand how it fits in with the bigger picture in order to get it right. Oops, so yep, we've got VLAN tagging set up, so we're going to have to assign a VLAN. So there we have it. Family VPLS is not valid on this interface. Okay, so neither is family CCC. And I think the reason for that is because of the encapsulation on the main interface. The encapsulation is VLAN VPLS, so anything that is not VLAN VPLS on the logical units is going to be rejected. Yeah, so, oh my god. I'm so confused. You know what I might want to do is just do all of these examples as they're given, and kind of set this aside here as a big time win. Just take the W. Yeah, so this is a huge win because we've got the VPLS functioning perfectly. So let's set this aside and not try to modify this topology, and just go through and do all three of these examples. Okay, so we can interconnect a layer 2 circuit with a layer 2 VPN. We can connect layer 3 VPNs to layer 2 circuits, and we can interconnect a layer 2 circuit with a layer 2 circuit. So let's start with this one, because I want to spend as much time on layer 2 circuits as possible. So it looks like we've got 1, 2, 3, 4, 5, 6 routers. Let's just start by reading the example. And even before that, let's go ahead and add these to my notes. Okay, so this is interconnecting a layer 2 circuit with a layer 2 circuit. This example provides a step-by-step procedure and commands for configuring and verifying a layer 2 circuit to a layer 2 circuit interconnection. It contains the following sections. Okay, so we're going to use a total of 6 routers. Overview and topology. The physical topology of a layer 2 circuit to layer 2 circuit interconnection is shown in figure 1. Physical topology of a layer 2 circuit terminating into a layer 2 circuit. The logical topology is shown in figure 2. Okay, so we've got much fewer routers for the logical topology. It looks like they're leaving out the P routers. Oh no, they're not. What are they leaving out? Okay, so we've got a layer 2 circuit. I guess I'm confused. I don't understand. Oh, I see. No, they're not. I guess they're leaving out PE. They're leaving out PE1 because the layer 2 circuit doesn't go through PE1. In any configuration session, it is a good practice to verify periodically that the configuration can be committed using the commit check command. Okay. Configuring PE router facing and loopback interfaces. Step-by-step procedure to begin building the interconnection. Configure the interfaces on the PE routers. If your network contains provider P routers, configure the interfaces on the P routers also. This example shows the configuration for router PE1 and router PE5. On router PE1, configure the GE1000 interface encapsulation. To configure the interface encapsulation, include the encapsulation statement and specify the Ethernet CCC option. VLAN CCC encapsulation is also supported. Configure the GE1000 10.0 logical interface family for circuit cross-connect functionality. To configure the logical interface family, include the family statement and specify the CCC option. Okay, and I'm guessing this is the interface to the CE. Yeah. Okay, so yeah, let's take this and run with it. We're gonna be let's go ahead and blank out the configuration of all the routers and just taking it and running it with it. We'll probably come up with our own addressing scheme. I really liked the scheme that we were using before, so we'll go with that scheme again, which is for the loopbacks 192.168.0.1, 2, and 3, and then it's .1, .1, 2, and 3, and then it's .2, .1, since we only have a single link there. So kind of like layers of an onion. And then for the physical interfaces, it's 10.0.1, 2, and 3, 10.1.1, 2, and 3, and then 10.2. 2. So it's okay, let me try it again. So it's 10.0.1, 2, and 3, 10.1.1, 2, and 3, and 10.2.1. Okay, so I think a good first place to start is just by blanking out all of the routers, because it's going to be completely different. We're just going to have layer 2 connections. We're going to have family CCC connections to the PE routers. That's quite a bit different from what we have right now. Right now we have family VPLS. Or we don't even have family VPLS, we have encapsulation VPLS connections to the PEs. Yeah, so here's the customer facing. We've got encapsulation VPLS. Alright, let's go and oh, so they're not giving any instructions for the CE, but I think that's okay. I think I can figure this out. So, but the first step is going to be just to blank everything out. Okay, I'm not sure what to do about this, but Yeah, I'm really not sure what to do about that actually. Okay, let's just add all of this. So we're gonna keep that. I don't know if it's necessary or not, but we'll keep it. Okay, so we're gonna keep with our theme of thinking of it like an onion. We're gonna start with the PE layer, and then go around and just set up the interfaces and the loopbacks as well. Oops, I got a message. I have a feeling I signed up for spam messages. Yeah, it's a spam message. I need a quick break again. This is like, I can't understate how, like, if anyone's watching this and they want to know one thing about studying for this exam, it truly is a nightmare. Like, it truly is difficult. It truly is rare that somebody would even study for this. So if there's one thing I can offer, if I haven't offered something of value already, it is my sympathies to anyone else who might be studying for this. I feel your pain. I understand your struggle. I will validate you in saying that you are working towards something worthy, something difficult, something really reflective of your character in a positive light. The fact that you're able to work towards this and put so much extra effort. And it's it might be at the expense of other things, but it's just to be able to succeed at anything at this high of a level, I think is a positive reflection of someone's character. Okay, so let's go ahead and set up the CCC interfaces, the layer 2 interfaces, and set up the loopback. Okay, so Ethernet CCC makes the whole port belong to this. You can also do VLAN CCC if you enable VLAN tagging. You can also do flexible Ethernet services, so you can provide this virtual circuit as well as internet service over the one port. So what I could do is say this customer wants like they're a bank, so that they're in Wisconsin, they want a direct connection to their bank in Michigan. they can purchase a virtual circuit from this ISP and hook up directly to their site in Michigan, but they can also purchase internet access, and it can be served on the same port. If you use flexible Ethernet services here, you can set up a Ethernet CCC port to connect their banks on a private line, protected from the public internet, and then on the same interface on a different VLAN, you can provide them with internet access, and then they can use their switch to separate the two out. So that's flexible Ethernet services. I recommend always configuring flexible Ethernet services, because going back later and reconfiguring the port, you'd have to do in a maintenance window. If you just enable flexible Ethernet services the first time, you can do Ethernet CCC, family, whatever you want to your heart's content. And if later down the line it turns out, oops, they wanted internet service as well, you don't have to have a maintenance window. You can just add the internet service. But we're going to go with what is in the documentation, just because I want somebody else to blame. Okay, perfect. Okay, so we're going to use the onion addressing scheme. So this is going to be the .1 layer of the onion, and it's going to be .1. So the .0 layer of the onion is the CEs, .1, 2, and 3. The .1 area of the onion is the PEs, .1, 2, and 3. And then the .2 layer of the onion is the Ps, but we've just got one link there, so it's just going to be .1. Oops, and it looks like they're using /24 here. I'm actually going to downvote 24 on the Linux. Alright, so yep, now we've got to go and configure all of them, which is what they're showing here, so we won't need to look at the configuration for the rest of those. Yep, and then after that we'll do the core facing interfaces. So right now what we're doing is configuring the CE interfaces and the loopback. We'll come back later and configure the core facing interfaces. We're also just focusing on the PEs right now. Okay, we won't need this help apropos anymore. Okay, I set it up to be nice and easy. I don't want to be thinking of extra layers of complexity when I'm already dealing with something so complex. So this is makes a lot of sense to me. Alright, we're back. We've got right. We've got the interfaces configured to the CEs, so now we've got to configure the core facing interfaces. Okay, so we're going to put family MPLS on those, and the core facing interfaces do need IP addresses. Okay, we won't need a encapsulation on those though. We can just leave it as the default encapsulation. It's going to be family INET address, and then we're going to use that onion addressing. So 10.0.1, 2, and 3, but this is going to be 10.1.1, 2, and 3. Okay, and then we'll have to assign a host address as well. That's the scheme for the network addresses, not the host addresses. Okay, so there we go. What else are we going to need according to the documentation? We'll need family MPLS. Yep. Okay, so we'll complete that and then come back and do the next step. Alright, so next up we're going to be configuring all the protocols necessary. They're going with OSPF. I'm a little bit concerned that I'm doing OSPF too much. I probably should be getting some more practice with ISAS. But OSPF is a lot easier. Given the choice, I think I would just use OSPF version 2 with traffic engineering every time. Except in production. If I were to be a network architect and I'd have to choose between OSPF traffic engineering and ISAS, I would definitely choose ISAS because of IPv6. So I'm a little bit concerned that my continued usage of OSPF version 2 in the lab might translate. And I'm more concerned not for myself, but for some other network architect that they might think, oh, well, let's just keep using OSPF version 2. Because when I configure my home lab, it makes things faster and easier to configure. It's like, no, this is not your home lab. This is production. We're gonna have changes over time. We might have IPv6 tomorrow. There might be a new requirement that we need IPv6 now. So you need something that's gonna make that a lot easier to handle. You have no idea what's coming down the pipe in the next even 3 months. All right, so yep. In addition to that, we're going to need okay, so okay, I've got it. Yeah, MPLS, OSPF, and LDP are what we're going to need. So let's add this to all of the PE routers.
right, so that's looking good to me. So the next step is going to be to configure the so in this step, actually, it said to configure the P routers as well. That's something I've been saving for later, but I think it's a good time to do that right now. Okay, and I do need another glass of water. I'll be back shortly. Okay, I'm back, and the P routers are ready to be configured. So we're going to require addressing. We're going to use the onion addressing. So this layer here is going to be 10.1.1, 2, and 3. So, and then the other side is going to be .2. Okay, and we might need a loopback as well. I'm actually not sure about that. Oops, and I need to configure more than just that one interface. This it is going to have 3 interfaces. Perfect. Okay, and now, yep, this is going to be 0 now, and we're going to increment, so it's one layer deeper into the onion, so it's going to be .2, and we'll only have one network that deep into the onion, so we'll make this, and then we'll make this the .1 address. We can make it either or, it doesn't matter. Okay, we just got to remember to do it on this side. Oops, so I got this wrong here. There we go. Did I get that wrong? How did I get that wrong? No, I got it right. Okay, perfect. So, yeah, now we're gonna need, I think we're gonna need loopbacks as well, so let's set those up. I'm actually not sure if we'll need those or not. Yeah, you know what? I don't think we're going to need loopbacks, so let's leave them out until it's evidence that they're required. But we will, of course, need protocols configured on the P routers as well. Just the same protocols we had on the PE routers. Okay, so now it's time for the actual layer 2 circuit. This procedure describes how to configure layer 2 circuits. In this example, the ignore MTU mismatch statement is required for the circuit to come up. On router PE1, configure the layer 2 circuit, include the layer 2 circuit statement, include the neighbor statement, and specify the loopback IPv4 address of router PE3 as the neighbor. Include the interface statement and specify GE100.0 as the logical interface that is participating in the layer 2 circuit. Include the virtual circuit ID statement and specify 100 as the identifier. Include the ignore MTU mismatch statement to allow a layer 2 circuit to be established even though the maximum transmission unit MTU configured on the local PE router does not match the MTU configured on the remote PE router. So this is basically what I was paid to do at my job with the ISP is find these MTU mismatches, and we actually decide. So one thing you can do is you can ignore them. Another thing you can do is correct the mismatch. I don't think there's a huge advantage in correcting the mismatch, but there you could end up in a situation if you just if you ignore the mismatch and don't correct it, where it's only allowing frames smaller than the frames you want to pass, and typically, especially for things like WAN. You want basically the largest frame possible. It's kind of the opposite of VoIP, where you want the smallest frame possible. For WAN, you want the largest frame possible. So if you just have ignore MTU mismatch on everything, you could encounter a situation where the frame size is too small. So it's up to the architect, the standards body, to decide if they just want to throw ignore MTU mismatch on it. But in the real world professional experience, you can find any sort of decision on that for good reasons. If you just throw ignore MTU mismatch on everything, you could end up with. You're not guaranteeing a certain frame size, and it can be important to make sure that you're always passing jumbo frames. So I'm not going to speak to my professional experience to say specifically what I did. That just sounds like a really bad idea. But what I will say is these kinds of MTU mismatches between layer 2 circuits are something that can be really valuable to know how to troubleshoot and resolve. Okay, so include the ignore MTU mismatch statement to allow a layer 2 circuit to be established even though the maximum transmission unit MTU configured on the local PE router does not match the MTU configured on the remote router. Alright, so let's set this up on router 4 and router 5. Okay, and it's going to be the customer-facing interface. Families TCC. and then of course we're going to need to configure the other side as well. Oops, so it looks like they're using a different virtual circuit ID. I thought the virtual circuit ID had to match. So on router PE5, configure the layer 2 circuit, include the L2 circuit statement, include the neighbor statement, and specify the loopback IPv4 address of router PE3 as the neighbor.
Include the interface statement and specify GE200.0 as the logical interface that is participating in the layer 2 circuits. Include the virtual circuit ID statement and specify 200 as the identifier, which is interesting to me. I thought they had to match. Maybe I'm thinking about pseudo wires, which is different. Include the ignore MTU mismatch statement and allow a layer 2 circuit to be established even though the MTU configured on the local PE router does not match the MTU configured on the remote PE router. So we're going to keep it with 200 with 100 just to see what happens with that mismatch. Another thing I'm going to do is configure trace options under there, because this is something I think I've been kind of messing up on. Is I should be having these trace options spamming my screen as I'm working on this, because I just need to get used to seeing this output for all sorts of things, because it's going to cue me right away to problems on the test, and I'll be able to save a ton of time if I'm used to looking at this sort of output. Okay, so we've got it down. So let's just see if right off the bat it's complaining about having those match when they're meant to be different. Okay, so I didn't see anything in that last one. I don't see anything popping up. So let's keep moving on here. On router PE3, configure the layer 2 circuit to router PE1. Include the L2 circuit statements, include the neighbor statement, and specify the loopback IPv4 address of router PE1 as the neighbor. Include the interface statement and specify IW0.0 as the logical interworking interface that is participating in the layer 2 circuit. Include the virtual circuit ID statement and specify 100 as the identifier. Include the ignore MTU mismatch statements to allow a layer 2 circuit to be established even though the MTU configured on the local PE does not match the MTU configured on the remote PE. On router PE3, configure the layer 2 circuit to router PE5. Include the L2 VPN circuit statement. Include the neighbor statement and specify the loopback IPv4 address of router PE5 as the neighbor. Include the interface statement and specify IW0.1 as the logical interworking interface that is participating in the layer 2 circuit. Include the virtual circuit ID statement and specify 200 as the identifier. Include the ignore MTU mismatch statement. Okay, so I'm not sure where this IW interface came from. I'm not even sure if I have it. Okay, yeah, I don't even know if I have it, so I'm not sure what that's all about. Okay, so it looks like they're calling for this on PE3, PE5, and PE1. Let's take a look at the topology.
PE3, PE5, and PE1. Okay, so they're almost... Yeah, so it looks like they want 2 virtual circuits going to PE3, and then PE3 is going to have that special IW interface. So it almost seems like, see, the way I was thinking of it was that you would have a router here and a router there, and then you would have a pseudo wire, like a virtual circuit connection like that between the 2 routers. But it almost looks like what they're having is you need that 3rd router, and then you're going to have a connection here, and then a connection here, and then this 3rd router is going to do some magic to create the connection between these 2. Okay, so I'm gonna follow along. I'm gonna be nice and follow along. Let's do a show L2 circuit connections and see if. Okay, so yeah, we've got a failure. So I'm gonna play nice, follow along. So this is going to be 200. Okay. So we've got a lot of messages. Okay, so it was recomputing the status of the VC, but I think that status is still going to be down. Yeah, it's going to be down until, oh, it's actually not down. The status is OL, no outgoing label, so, and it's because we don't even have, we don't have that 3rd one set up yet, so let's do that. Okay. Yeah, see how this 3rd one's going to get through those, and then it's going to have the IW interface. So, yep, so we finished that. This is going to get 200. So here we go. On to the 3rd one, router 6. So I'm not sure where this IW interface comes from. Oh, it comes from here. So we're gonna configure this first and configure that second. I think a commit probably won't go through, but let's try it. Okay, and it looks like I went with the neighbor that they used. I'm going to need to use my own neighbor. So R5 had 200, so let's go with R5 first. Okay, now it's time for R1, which has the ID of 200. So I was right that they have to match, but they match, yeah, I was right that they have to match, but they're going to be matching through a third party, like that IW interface has to be involved. So let's see here, we've got and we're going to do 100. Okay, so I don't think it'll commit yet. We'll try it. But yep, everything looks good. Alright, so the next step for interconnecting the layer 2 circuits is on router PE3, the router that is stitching the layer 2 circuits together using the internetworking interface. The configuration of the peer unit interfaces is what makes the interconnection. Oh, that's interesting. It was able to actually commit without even configuring that port yet. On router PE3, configure the IW0.0 interface, include the encapsulation statement and specify the Ethernet CCC option, include the peer unit statement and specify the logical interface unit 1 as the peer tunnel interface. On router PE3, configure the IW0.1 interface, include the encapsulation statement and specify the Ethernet CCC option. Include the peer unit statement and specify the logical interface unit 0 as the peer tunnel interface. Oh my god, this is so complicated. Okay. Yeah, so layer 2 interworking, it's going to be L2, oh, okay. So IW stands for interworking. Okay, so it says on each router commit, I don't know what that means. I'm just going to commit it on this router. Okay, so that's all there is. So next is going to be the verification step. So verify that the L2 circuit connection on router PE1, which in my case is router 4, is up, the LDP neighbors are correct, and the MPLS label operations are correct. Let's see if we got anything special from, aha, so we already know that it's up because we got those trace options going, but let's do the verifications given in the example. On router PE1, use the show L2 circuit connections command to verify that the layer 2 circuit from router 1 to router 3 is up. Oh, and it looks like it is in fact not up. On router 1, use show LDP neighbor. Yeah, that looks okay. router use show route table MPLS 0 to verify the L2 circuit is using the LDP label to router PE3 in both directions, push and pop. In the example below, the layer 2 circuit is associated with LDP label. We're going to have a different one. And actually, in this case, it's not going to be associated with the label because it's not a. In fact, that's the problem it's happening. It can't associate with an outgoing label for some reason. On router PE3, use the show L2 circuit connections command to verify that the L2 circuit from router PE3 to router PE5 is up, that the layer 2 circuit from router PE3 to router PE1 is up, that the connections to router PE1 and router PE5 use the IW interface, and that the status for both logical IW0 interfaces is up. Okay, it says something came up. I don't know what came up. It's clearly not a L2 circuit connection that came up, whatever it is. Yeah, we're in no outgoing label. Huh. Are all my BGP neighborships up? Oh, I don't even have BGP running on R6. Oh, I don't have BGP running here either. I thought I didn't need it. Oh, yeah, because this is the relevant sample configuration, so they might be missing one. Oh. Maybe it's because I'm missing this forwarding options hash key. But it doesn't look like this is applied anywhere. Or maybe it's not a. Maybe I'm actually applying it to the. Yeah. So let's try this. And then yeah, it's not a name. It's an actual feature. Okay, let's try adding this to all the PEs. Yeah, so the VC still isn't present. Okay, so here we go. So yeah, this one's really good. We're adding this to the notes. Okay, so we've got OL status here. So the correct OL status, make sure your LSPs are up and running, and confirm that outgoing labels are available for the egress PE from this PE. So let's do a show MPLS LSP. Here we don't have any. Show LDP session. Seems to be fine. Make sure that core interfaces are up and have family MPLS configured. I mean, definitely have that. That's the easy one. Check the MPLS.0 table and RSVP or LDP session. Yeah, I'm not sure what I'm looking for. I mean, it looks fine, right? Open, operational. Operational sounds good to me. Check advertise label blocks using show VPLS. Oh, okay, so yeah, I think I'm supposed to have a BGP connection because the advertising protocol is supposed to be BGP for LDP. Yeah, I'm supposed to have a BGP connection, so let's add that. We'll call it L2Circuit. We'll call it I don't know what to call it. It's called L2Circuit. Set local address. One, set type internal, set number 2 and 3. Okay, and then oh yeah, we need to set the family on it. Okay, now here's where it gets interesting. So it's not going to be INET because it's going to be layer 2. I think it's going to be L2 VPN. Yeah, and we don't even need the word signaling. Let's just add it anyways because you get both. So I'd rather have too much and it work than not enough and it not work. Okay, so that looks good to me. Oh, we need a local autonomous system. Let's go with AS. So options autonomous system. Let's go with 200. Well, let's just go with 100. I'm just hesitant to use the same autonomous system that we're using for labeling. the L2 circuits. I just think that would get confusing. So let's go with 10. Okay. Okay, so on to the next one. This is going to be .2. So we'll need connections to .1 and .3. Yeah, of course, because this is what actually carries the traffic. This family L2 VPN signaling is absolutely essential. I think this is going to work. Got high hopes. Still nothing. So I know this is the wrong signaling, family INETs. I don't know anything. I'm really confused right now. I do know that I thought LDP required oh, here we go. So we've got a mode here, DU. I'm not sure what DU means. Downstream unsolicited, that's what that means. So yeah, it's been up, it's up, that's for sure. Yeah, it's receiving like next hop addresses and stuff. So it seems good to me. Yeah, I don't see what the problem would be. I have no idea why this is not working. I think it's because I'm missing some key piece of the configuration, because they're being all like coy and they're like, oh, you know, this is just a relevant sample of the configuration. It's like, well, what's the irrelevant stuff? Because the irrelevant stuff obviously seems quite relevant. If I don't include the irrelevant stuff, the relevant stuff doesn't seem to work. Okay, we do have a L2 circuit table now, which is interesting. I'm not sure why. Now let me try something. Let me try rolling back my BGP configuration. and seeing if that L2 circuit table persists. It does. Why do we have a L2 circuit table? Oh, it's probably because I created an L2 circuit. Yeah, because I have this protocol's L2 circuit, so we've got an L2 circuit table now. Okay. Yeah, I have no idea what could be the problem. I mean, I have nothing to work with here. They gave me it and it didn't work, so don't need family at MPLS on the loopback. Like, I mean, they don't say that it's required there. Yeah. Yeah, just on here. Okay, so it looks like I got another half an hour before my cron job, so I'm kind of tempted to throw in the towel, but I'll be automatically booted out at in a half an hour, so I might as well keep going. Oh man, I need to drink more water today. Oh my god, yeah, I'm getting so fat. It's hard. It's just hard because I used to do a bunch of stuff before the pandemic, and like I'm starting to like try to get back into it. Like I used to go indoors every Thursday and meet up with people in the community to do some juggling, and it's like that's like the worst thing you can do during a pandemic now. We would share props and not wash our hands afterwards, and it's like I just can't do that. And it used to be like a fair bit of exercise every Thursday. I would sweat, I would pant, and that's even worse. It's definitely we're all sweating and breathing hard in a small room together. It's like I'm starting to do it on Tuesdays now instead of Thursdays outside. And I've been wearing a mask. I'm sure I don't need one if I'm outside and it's windy and all that. But I just feel like, if there's one thing I can do in a situation that's just a flood of tsunami of things I have no control over, and I can wear a mask and it will it's just one thing I can do. I have control over whether or not I wear or don't wear a mask. And wearing a mask actually has some way of help. It's like, I'm going to do it. I want to help. I want this situation to be over. I want to go back to business as usual. So I'm going to... that's my reasoning for wearing one in that particular situation, because in that situation it probably is unnecessary, but I just kind of want people to know that I care about this situation ending. Okay, so let's go ahead and yeah, and there's a really good, I'm trying not to, I'm really off focus here right now, but there's a really good chart where you have on the top something you tried and something you didn't try, and then on the left hand side you have something that worked and something that didn't work. So you have 4 squares. One is something that worked and you tried. The one under that is something that didn't work and you tried. The one to the right is something that worked and you didn't try, and the one in the bottom is something that didn't work and you didn't try. So there's 2 big squares that you want. You want either the square, you definitely want the square where it worked and you tried it. That's the most important square to get. Another really important square to get is the one where it didn't work and you didn't try it, because then you just didn't waste your time, you didn't waste your your money, all that. But there's two squares which are kind of depend on what's actually happening. The first square is something that worked but that you didn't try. So, there's all kinds of good reasons you wouldn't have tried something. It costs you too much in terms of time instead of money. So if it worked and you didn't try it and it was something that would have cost you, $1 million, or, it just would have been impossible for you to try it, that's understandable. But if you're missing out on something that worked and you didn't try it just because, you literally just had to wear a piece of cloth over your mouth for, a few hours, like that's pretty sad in my opinion. Like, there's a possibility for it to work. Trying it is basically no cost to you. So it's really important to, according to all the research, according to a lot of experts, this is actually something that's not in that square of it doesn't work. In that square of it doesn't work. It seems pretty clear that it's in the square of it worked, but you always have those four squares for any action you did. Something that works and you tried, something that works and you didn't try, something that doesn't work and you tried, and something that doesn't work and you didn't try. So you always need to think about all your actions in terms of which of those squares it will fall in and what are the consequences of each. So with wearing a mask, if it doesn't work and you didn't try it, what are the consequences of that? Simply, you didn't have to wear a mask. And how big of a problem is wearing a mask to you? To me, it's really not that big of a problem. So I'd rather do you tried it, because then I only have those two squares to worry about, where I tried it and it didn't work, which isn't that big of a deal to me. Just wearing a mask for no reason is not a big deal for me. And then trying it and it worked, that's really where I want to get. I think we all need to try to aim for that square on an individual decision-making basis, and aiming for the square where it didn't work and you didn't try it, in my opinion, is not that great of a strategy. When it comes to this pandemic, you want to be aiming for that it worked and you tried it square, as much as you can. So trying things that are basically no harm, no something like that, is really, really important. So for like me, I took vitamin D for the first time. I took a little bit of vitamin C for the first time. I'm not really doing that now just because, like, I don't know, like my health is, like, I'm gaining a lot of weight and I'm just not feeling very healthy, and it's like, I just think like getting my diet in control is going to be the most important thing. So I've been making a lot of experiments with diet, and lately I've just been stopped taking the supplements because my diet is just completely out of control and I want to get that under control. So I'm working to do that. Unfortunately, I had a big mistake, and I found some great restaurants I love that are making me fat. But you can see just how out of control my brain is right now. I really can't think about this. I'm thinking about other things. This would be a good time to take a break, just because my brain is so off the rails right now. But unfortunately, I'd rather not take a break for another 15 minutes because that cron job's gonna kick in. I might need to just go and call this one good, and move on. I'm really just not sure what the problem is. I do seem to be missing an LDP neighbor. Am I? No, I'm not missing an LDP neighbor. Am I missing an LDP neighbor? No, I'm not. Yeah, I can't even tell if I'm missing neighbors or not, because I don't even know which neighbors are meant to I meant to form with. But I thought LDP would be something like RSVP, where you would form it to you're directly connected, but obviously it works differently than that. And I obviously don't have a super good understanding of LDP. But you know what? I think I'm going to say that this is good to go. And I'm going to move on to the next one. So kind of taking a little bit of an L here, just because I didn't get the circuits to come up, but I don't know why they're not coming up. It might not even be with me. Oh, you know what I'm going to do? I'm going to do a trace options file on LDP. Yeah, I was actually, my brain is still like completely off track. I apologize for that, but I just kind of want to get this thought. Well, actually, I don't want this thought to be on my technical study for the JNCIE-SP channel, but okay. So yeah, let's stay focused and let's do a monitor start. So, okay, now, yeah, this is perfect. Okay, so we've got, lots of things going on here. Okay, yeah, so we're receiving hellos. This is basically, like, these trace options files, when you enable all of them, it's basically like a packet capture. Like, it's really good. I like these trace options files. Yeah, there's really nothing useful, I think, though. Okay, you know what? I'm really not doing anything super useful right now, so I think what I'm going to do is monitor stop, and then I'm going to do a, I'm going to end this video here. It's already an hour and 40 minutes, so in the next video we'll be going over the next way to set this up, which is going to be let's do L3 because we'll save the L2 for to tie into the next topic. And I am gonna skip over EVPNs. The most important thing to remember with EVPNs is just the 304 subnet mask, I think, and then it's basically just like any other VPN. You're just using different keywords. So really not hard to understand. New kinds of VPNs if you're really familiar with one already, and I'm starting to feel pretty confident with VPLS and L3 VRF VPNs. So yeah, so that's going to be it for this video. Unfortunately, I couldn't quite get that to work. I have no idea what the problem is. I wish I knew. I'm really sad that I don't know. But anyways, stay tuned for the next one where we do the next example for L3 VPNs.